All right, so we are going to talk about a new number today, which is the number e. You can actually find this on your calculator. So let's see here. If you look right above the LN button, which we're going to talk about that today as well, right above this button is e to the x. So if I do second natural log, and then we're going to do e to the first, because e to the first is just e, we get about 2.718. And remember, I like 3 decimal places, so that's why I said 2.718. Now that's what it's approximately equal to. So here's how they came up with that number. And before I do that, on number 4 here, the person who discovered E is Euler. So he discovered that E, which is also e to the first, is the same thing as 1 plus 1 divided by 1 factorial plus 1 divided by 2 factorial plus 1 divided by 3 factorial. Hopefully you see a pattern here. He kept on adding that. Now if you recall factorial, so 3 factorial, that just means 3 times 2 times 1. So e is just kind of like pi. It's irrational, which means that it is non-terminating and non-repeating. So it goes on and on forever, and it doesn't repeat. Non-terminating, non-repeating. Okay. So the reason inverse is on here again, because we talked about that in chapter 4, is because logs, which if you look down here on 12, 14, and 16, these are logs, and that's natural log. They're just the inverse of exponents, so we're going to refer back to inverses as well. So if xy is on the original, yx is on the inverse. And I don't really care about 6 or 7. We don't really need to know all that at this time. Okay, let's see. Let's also cross off, because some of these examples are the same. Let's cross off 13 and 14. And 16 for now, it looks like. Okay, so I am going to give 2 names for the inverse function. Well, one of them is just by switching x and y around. So let me get a different color here. Oh, I can only find a pencil. No, wait. All right, I found a red one. Okay, so one of the inverses is going to be just switching x and y. So x equals log base 3y. So that's one way to write the inverse. Okay, so another way to write the inverse is first to rewrite the log equation in exponential form. And to do that, this little number, that is going to be our base. And then y becomes the exponent, and then it's equal to x. So it goes 3 to the y equals x. It's kind of like these two switch places. So if 3 has the x in the log equation, it's going to have the y in the exponential equation. So these two things mean the same thing. So now I need another inverse, because I want 2 inverse functions. So all I have to do now is switch x and y on the exponential equation. So 3 to the x equals y. So these two would be my answer. Okay, let's move down to 15. So what I need to do first is write down one of the inverses just by switching x and y. So x equals 1/2 to the y power. The other one has to be in log form. So let's go back to this one. I want to make the equivalent of this but in log form. So I have log base 1/2, and since 1/2 has the x with it up here, it's going to have the y with it down here. So these two things mean the same thing. So now I'm going to write the inverse of this one. Oh, I forgot to use a different color. Oh well. So I'm just going to switch x and y around. So now I have my two inverses. Okay, so that's 12 and 15, writing the inverses. Okay, so let's go down and look at 17. So the inverse of y equals b to the x, that's the same thing as x equals b to the y. Because again, I just switched my x and my y around. But again, I need another one. So I need to write, first of all, this in log form. So log base b, x and y are going to switch places. So if b has the x up here, it's going to have the y down here. So these two things mean the same thing. So then the other inverse would be this, except x and y are switched. So log bx equals y. All right, and then we have the inverse of y equals e to the x. That's just going to be x equals e to the y. There really should be another blank here. Now, I used log on the other ones, but on this one I'm not going to use log because the base is e. Whenever your base is e, you have to use natural log. So natural log, my base is e, but if your base is e, you don't have to put it, because that's the only time you use natural log is when your base is e, so it's understood that it's there. And then again, x and y will switch places, so this is y equals x. So now I know the other inverse is natural log of x equals y. Okay, so this is fairly new. You've never seen logs before, unless you took chemistry, I believe. But anyway, so I'm not going to do 19 or 20 because that was yesterday's lesson, and we just did an opener over that. But if you weren't here for the opener, I guess, yesterday or in 5.1, x was the exponent, so you couldn't cross the x-axis. So let me just do this really briefly. So x was the exponent, so 1, 0, -1 goes in the x spot, and you can't cross the x-axis. Well, today we're going to graph logs, and it's the opposite. Okay, let's turn the page. So on this next page, they're all logs. And let's see, I'm going to cross off some of these. I'm going to cross off 21. I'm going to pick some of the harder ones. And I don't know, maybe 23? Okay, that should be good. All right, so in order for me to graph this, I have to rewrite this in exponential form. So it has to look like that. So to do that, I have to rewrite this like I did on the front page. So 1/5 is my base, and then y is going to be my exponent, and then it's equal to x. So these two things mean the same thing, but it's easier to graph if it's in exponential form. So just like what I did on 5.1, I'm going to make a table. However, this time, y is the exponent. So that's where 1, 0, -1 is going to go in the y spot. And then 1/5 is my base, so 1/5 goes next to 1, or yeah, 1. Next to 0 is 1, and then next to -1 is always the reciprocal. All right, so y is the exponent. So this time I can't cross the y-axis. So I can't cross this. So I'm going to go ahead and plot those points from my origin. So over 1/5 up 1, 1, 0, and then 5, -1. I'm going to go ahead and connect those. And that is what my graph will look like. So this is log decay, because it's decreasing from left to right. Okay, 24. Before I write my exponential form, I need to move my origin. I didn't have to do that on the one before because I didn't have any extra numbers. But this is x plus 2. So I need to go to the left 2. That is my new origin. So I don't really care about this 2 anymore. So now I'm going to rewrite it. So 4 is my base, and then it's going to be y to the x power, or 4 to the y power equals x is what I mean, sorry. All right, and then since y is the exponent, 1, 0, -1 is in the y column, and then I'm going to have 4, 1, and 1/4. And since y is the exponent, I cannot cross the y-axis. So if you're not sure if x or y is the exponent, whenever you have a log, y is always going to be the exponent. All right, so I'm going to plot those points from there. So 1, 2, 3, 4, 1, 1, 0, and then 1/4, -1. And I can't cross the new y-axis. So that's what my graph looks like for 24. Okay, moving on to 25. All right, so first I have to move my origin. So I'm going to go to the right 2, up 1. There's my new origin. These numbers are now gone. Okay, so now once I move my origin, I'm going to rewrite my equation in exponential form. So I got 1/3. And then since I see a log in my equation, y becomes the exponent. And I'm ready to make a table. Since y is the exponent, that's where I put 1, 0, -1. So then I'm going to have 1/3, 1, and 3. And before I plot those points, I have to remember that since y is the exponent, I cannot cross the new y-axis. So now I'm ready to plot those points from my origin. So over 1/3 up 1, 1, 0, 1, 2, 3, -1. And then I connect. So this one's also log decay, and I forgot to mention 24 is log growth, because this one it's increasing from left to right, this one's decreasing from left to right. Okay, 26. So the first thing I'm going to do on this one is go down 2, because that 2 isn't grouped with x, it's just x minus 2 with no parentheses. So go down 2, and that number is not there anymore. So I'm going to have 3 to the y equals x. Now I do have a negative, but I'll worry about that after I make my table. All right, I'm going to put 1, 0, -1 in the y column. So I'm going to get 3, 1, and then 1/3. Okay, so this is negative. So just like with exponential growth and decay, if this negative was right with the x's would change. Since the negative is not with the x, the y's change. So I'm going to change all these y values to their opposite sign. That becomes a -1, that becomes a +1. And I cannot cross the y-axis, which is still right here. So I'm going to plot those points. So 1, 2, 3, -1, 1, 0, and then 1/3 up 1. And I'm going to connect those. This one is also log decay because it's decreasing as you go to the right. Okay, let's move on to page 3. All right, so on page 3, we have different things going on here. I'm gonna actually cross off, I don't know if I should cross off any really. I want to, but they're all kind of different. All right, I'm just gonna do them all, I guess. Okay, so if you look at 27, 28, and 30, they have a base of an E. If you look at 29, 31, and 32, they all have natural log. Now for some reason, I don't know why it's not NL for natural log, it's LN instead. Don't know why, it just is. So if you see natural log, that means it's a log. So if you see a log or natural log, you're gonna have to rewrite those in exponential form. But 27, 28, and 30, they're already in exponential form. I already see an exponent. Okay, so I'm gonna make a table. Now this time, x is the exponent. So I'm gonna put 1, 0, -1 in the x column. Now on the very first page, we said e to the first was 2.718. This is still gonna be 1. If I do e to the negative first, so let's see, second natural log, e to the negative first, we get 0.367. 0.367. All right, so I am going to not be able to cross the x-axis this time because x is the exponent. So I'm going to plot those points and connect. So that's what number 27 looks like. Now, since 28 and 29 also have a base of an E, I'm going to use this same table. But on this one, since the x has a negative with it, these are going to change to the opposite. So I actually should probably write this one down. Okay, so that's the same table. However, again, since there's a negative there, the x's change to their opposite. I gotta draw this in. I can't cross the x-axis. Now I'm gonna plot those points. So there's 28. Okay, 29. So first I have to go down 2, because I have an extra number there. And after I go down 2, I don't really care about that number anymore. All right, so I'm going to use this table because, again, my base is E. But before I plot those points, I got to draw on my x-axis. And I'm going to plot those points. And I can't cross the x-axis. So there's number 30. Okay, so that's how you do 27, 28, and 30. If you have a base of E, you just use the same table for all of them because they have the same base. All right, the last 3 are natural log. And I mentioned on the first page that if you have natural log, your base is E. So not having something there implies there's an E there. So on 29, or actually on all 3 of these, I have to rewrite those in exponential form. So if you see a log or natural log, y becomes your exponent. Now, I'm going to use the same table pretty much. The only difference is that since y is the exponent, those become the y's and those become the x's. So I'm going to rewrite this table. So since y is the exponent, the 1, 0, -1 goes in the y column. And then the other numbers are in the x column. Okay, this time y is the exponent, so I can't cross the y-axis. And now I'm going to plot those points. So there is 29. Okay, let's take a look at 31. So before I rewrite it, I have to go down 3 first. Okay, I don't need that anymore. Now I also have a negative, but I'll worry about that in a second. So I'm going to use the same table. The only difference is that this negative means I'm going to change the y values. I only change the x values if x had a negative in front of it. So this becomes a -1, and that becomes a +1. Before I plot those points, I'm going to draw this in. Okay, so I'm going to go over 2.718 down 1, because remember I have to change these to their opposite, and then 10.67 up 1. So there's 31. And finally 32, I have to go to the left 2, up 1 first. Okay, those numbers are now gone. All right, now I have to rewrite that in exponential form, which I didn't do over here. Forgot to do that. I guess I just assumed I did that. Okay, so over here, same thing. Since you have a natural log, or if you had a log, y becomes the exponent. So these are the same, just like it was for 29. So I'm going to use the exact same table. Before I plot those points, I cannot cross the y-axis. Now I can plot those points. I don't have any negatives, so I'm going to use exactly those points. And then connect. And by the way, these two would be log growth. This would be log decay. These don't have a log with them, so this would just be exponential growth for these two, and this would be exponential decay. All right, last page here. So now we're gonna just do some characteristics. So this would be if my base was greater than 1, so it would be log growth, and this would be log decay. So I can't cross the y-axis on these. Well, they're both continuous. I don't have any breaks in my graph. The range for both of these is all real. Let's get back to the domain. So the domain are the x values. Looks like everything for log is on the positive side of the x-axis. So all of your x values are going to be greater than 0. I have an x-intercept this time. I didn't have any when I did 5, 1, but this time I do, because again, they're inverses. So the x-intercepts are going to be at 1, 0. I don't have any y-intercepts. I do have asymptotes. This time it's the y-axis. Can't cross the y-axis. Okay, in behavior. So on growth, as I go to the right, my graph is gradually going up. It's going to gradually keep going up. On this one, it's going to gradually keep going down. It looks like it's flat, but it gradually just keeps going down. So this is going to be negative infinity. Now, these can't be done because it doesn't go to negative infinity. I don't have anything on the left side because my y-axis prevents me from going to the left side. Okay, function. If I pass, or I got to see if it passes the vertical line test. They both do, so they're both a function. And they're both monotonic. The first one increases and the second one decreases. So I'll just put I for increase and D for decrease. And that is all.